Tell me about a time you had to balance speed and long-term design introduction. This is an important behavioral and technical interview question for software developers, senior developers, backend developers, full-stack developers, team leads, and engineering managers. Interviewers ask this question to understand how you handle delivery pressure, how you avoid overengineering, how you avoid creating unnecessary technical debt, how you make practical trade-offs, how you deliver quickly without damaging long-term maintainability, how you communicate risks and assumptions. This question is especially important for check Java developers, check backend developers, check Spring Boot developers, check full-stack developers, senior software developers, check cloud developers, check team leads, check engineering managers, check system design interviews. The best way to answer this question is by using the STAR method. STAR means S. Situation. Explain the background. T. Task. Explain your responsibility. A. Action. Explain what you personally did. R. Result. Explain the final outcome. A good interview answer usually spends 10% situation, 10% task, 60% action, 20% result. The most important part is the action section because interviewers want to understand how you made the trade-off between fast delivery and good design. Question: tell me about a time you had to balance speed and long-term design. Example 1. Delivering an API quickly without overengineering situation. In one project, the business needed a new API quickly for a front-end feature. The deadline was tight because the feature was needed for an upcoming release. At the same time, we knew the API might be reused by other screens later. Task: I was responsible for designing and implementing the API quickly while keeping the design clean enough for future extension. Action: I started by clarifying the minimum requirements needed for the release. I identified check required request fields, check required response fields, check validation rules, check authorization rules, check expected front-end usage, check possible future extensions, check performance expectations. I avoided designing a very large generic API for every future possibility. Instead, I designed a focused API that solved the current business need but used clean patterns. I created clear endpoint naming, click request DTO, click response DTO, validation rules, click standard error response, click service layer separation, click repository layer separation, click unit tests for business logic, click integration tests for API behavior. To support future changes, I avoided exposing database entities directly. I also documented which fields were included for the first release and which future fields could be added later. Result: the API was delivered on time. The front-end team integrated it easily because the contract was clear. Later, when the API needed additional filters, we extended it without major rework because the foundation was clean. Why this answer works? This answer is strong because it shows fast delivery, practical API design, avoiding overengineering, DTO usage, clean layering, future extensibility, testing. Example 2. Choosing a simple solution first with a refactoring plan situation. In one application, we needed to add a new validation rule quickly because it was blocking a release. The long-term ideal solution was to redesign the full validation framework, but that would take more time than the release allowed. Task: I was responsible for implementing the validation change quickly while avoiding a messy short-term fix. Action: I reviewed the existing validation logic and identified the smallest safe change needed for the release. Instead of redesigning the whole validation system immediately, I added the new rule in the existing validation flow. However, I made sure the change followed the current code style and did not introduce duplicate logic. I also documented the limitation and created a follow-up task to improve the validation structure. The immediate change included clear validation method, meaningful error code, field-level error message, unit test for valid input, unit test for invalid input, regression test for existing rules. After the release, I worked on the longer-term improvement by moving repeated validation rules into a shared validator component. Result: the release was not delayed. The new validation rule worked correctly. The follow-up refactor reduced duplicate logic and made future validation changes easier. Why this answer works? This answer is good because it shows: check, balancing short-term and long-term work, controlled technical debt, follow-up refactoring, release awareness, testing discipline, ownership. Example 3. Balancing speed and scalability in a search API situation. In one project, users needed a search feature quickly. The first release needed basic search by status and date range. However, we knew that future requirements might include more filters, sorting, and larger data volume. Task: I was responsible for delivering the first version quickly, while designing the API so it could scale later. Action: I started by separating immediate requirements from future possibilities. For the first release, the API needed status filter, date range filter, page number, page size, basic sorting. I designed the endpoint with pagination from the beginning, because returning all records would create future performance problems. I also added maximum page size to avoid large unbounded requests. I kept the query implementation simple, but structured it so new filters could be added later. I added indexes for the first release's most common filter pattern. I avoided adding a dedicated search engine immediately because the current dataset and requirements did not justify that complexity. However, I documented that if search became more complex, we could evaluate Elasticsearch or OpenSearch later. Result: the first version of the Search API was delivered quickly. It handled current data volume well. Later, when more filters were added, the API structure supported the changes without major redesign. Why this answer works? This answer is strong because it shows, speed versus scalability trade-off, pagination, database indexing, avoiding premature complexity, future planning, practical system design. Example 4. Delivering a feature with temporary manual step situation. In one project, the business needed a reporting feature quickly. The ideal long-term design was a fully automated report generation pipeline, but the first release had a tight deadline. Task: I was responsible for helping deliver the report feature quickly while keeping a path open for future automation. Action: I worked with the team to separate the release requirement from the future ideal design. For the first release, users only needed the report once per day. So, we delivered a simpler version where the report data was generated by a scheduled backend job and reviewed before publishing. I designed the backend in a way that supported future automation. The first version included scheduled job, report status tracking, report metadata table, validation of report data, clear error handling, logging for job execution, audit trail for report generation. I avoided hard coding assumptions that would block future automation. I also created a backlog item for the next phase to automate publishing and notifications. Result: the report feature was delivered on time. The first version met the business need. Later automation was easier because the first version already had status tracking, metadata, and logging. Why this answer works? This answer is good because it shows: check MVP thinking, check future-proof design, check practical delivery, check avoiding hard coding, check phased implementation, check business alignment. Example 5. Balancing quick fix and proper architecture during production issue situation. In one production issue, an API was failing for users with a specific optional field missing. A full redesign of the validation logic would take longer, but users needed the issue resolved quickly. Task: I was responsible for helping fix the production issue quickly, while also making sure the long-term validation design was improved later. Action: I first analyzed the issue and confirmed that the failure happened only for one specific optional field scenario. For the immediate fix, I added a small safe validation change to handle the missing optional field correctly. I made sure the quick fix was narrow and low risk. The immediate fix included null check for the optional field, clear validation behavior, unit test for missing field, unit test for present field, regression test for existing behavior. Then I created a follow-up task to improve the broader validation design because similar logic existed in multiple places. After the production issue was resolved, I refactored the repeated validation logic into a shared validator. Result: the production issue was fixed quickly. Users were able to continue using the API. The later refactor reduced duplicate validation logic and helped prevent similar issues in the future. Why this answer works? This answer is strong because it shows production urgency, safe quick fix, long-term improvement, ownership, risk control, regression testing. Example 6, balancing speed and database design situation. In one project, we needed to store new audit information for a feature. The fastest option was to add several columns to an existing table. However, the long-term design might require storing multiple audit events per record. Task: I was responsible for recommending a database design that supported the release but did not create future data model problems. Action: I reviewed the current and future audit requirements. The immediate release needed to track. Capital Q performed the action. Capital N performed the action. Future requirements might include multiple actions per record and audit history display. Adding columns to the main table would be fast, but it would not support multiple audit events cleanly. So, I recommended creating a separate audit table from the beginning. The audit table included check audit ID, check business record ID, action type, status, created by, created timestamp, optional metadata. This took slightly more time than adding columns, but it avoided a future migration. To keep the release on track, I kept the first version of the audit table simple and added only the fields needed now plus safe extension points. Result: the feature was delivered within the timeline. The audit design supported the first release and later audit history requirements. The team avoided reworking the database model later. Why this answer works? This answer is good because it shows good. Check. Database design trade-off. Short-term versus long-term thinking. Audit table design. Avoiding future migration. Practical scope control. Example 7. Balancing speed and security situation. In one project, we needed to expose a new admin API quickly. The business wanted the feature in the next release, but the API controlled sensitive configuration. Task: I was responsible for implementing the API quickly, without compromising security. Action: I started by identifying the minimum secure requirements. Even though the deadline was tight, I did not treat security as optional. I added, quote, authentication, role-based authorization, admin-only access check, input validation, audit logging, secure error responses, tests for unauthorized access, tests for valid admin access. To avoid delaying the release, I kept the first version of the API focused on only the required admin action. I did not add extra future admin features in the first release. I also documented future enhancements, such as more detailed approval flow and expanded audit reporting. Result: the admin API was delivered on time and securely. Unauthorized users were blocked. The focused first release reduced scope while still protecting sensitive operations. Why this answer works? This answer is strong because it shows speed without skipping security, role-based access, audit logging, scope control, secure API design, practical delivery. Example 8. Balancing speed and long-term front-end design situation. In one full-stack project, the front-end needed a new dashboard page quickly. The first version had only a few metrics, but the business expected more widgets and filters in future releases. Task: I was responsible for helping design the front-end and back-end flow so the dashboard could be delivered quickly, but remain extendable. Action: I started by identifying the minimum dashboard widgets needed for the first release. Instead of building a complex dashboard framework immediately, I created a simple component structure. The design included reusable card component, reusable loading state, reusable error state, API response DTO for dashboard metrics, backend endpoint for summary data, simple filtering support, clear separation between data fetching and display. I avoided over-engineering with too many abstractions. At the same time, I avoided hard-coding each widget in a way that would make future changes difficult. I also worked with the backend team to make sure the API returned only the data needed by the dashboard. Result: the dashboard was delivered quickly. The first version was simple and maintainable. Later, when more widgets were added, the reusable component structure helped the team extend the page faster. Why this answer works? This answer is good because it shows front-end, back-end design balance. Check. Reusable components, avoiding over-engineering, fast delivery, future extension, maintainability. Best short answer version. If you need a short interview answer, you can say, in one project, the business needed a customer search API quickly for an upcoming release. The immediate requirement was basic search by status and date range, but we knew future versions might need more filters, sorting, and larger data support. I was responsible for delivering the API quickly while keeping the design extendable. I separated the immediate requirements from future possibilities. For the first release, I designed a focused API with status filter, date range filter, pagination, page size, and basic sorting. I added pagination from the beginning because returning all records would create future performance problems. I avoided adding a dedicated search engine immediately because the current dataset did not justify that complexity. However, I structured the code so new filters could be added later and documented when we should consider a search engine if requirements grew. As a result, the first version was delivered on time, handled the current data volume well, and later filter additions were added without major redesign. Common mistakes to avoid. 1. Choosing only speed. Bad answer. We needed it fast, so I just added a quick fix. Better answer. I delivered the smallest safe solution while keeping the structure clean enough for future changes. 2. Over-engineering. Bad answer. I built a full framework for possible future needs. Better answer. I avoided over-engineering and focused on current requirements, but designed the API and code structure to be extendable. 3. Not communicating trade-offs. Bad answer. I made the decision myself. Better answer. I explained the short-term approach, the trade-offs, and the follow-up improvement plan to the team. 4. Creating untracked technical debt. Bad answer. We planned to fix it later. Better answer. I created a documented follow-up task and scheduled the refactor after the release. 5. Ignoring tests. Bad answer. We moved fast and tested manually. Better answer. I added focused unit and regression tests to make sure the fast delivery did not break existing behavior. Best practices for answering this question. Use the STAR method. Explain the time pressure. Explain the long-term design concern. Separate current requirements from future possibilities. Explain the trade-off clearly. Avoid over-engineering. Avoid careless shortcuts. Add tests for safety. Document assumptions and follow-up work. Practical impact. What interviewers are looking for. Interviewers want to see whether you can deliver under pressure. Make practical trade-offs. Avoid over-engineering. Protect long-term maintainability. Control technical debt. Communicate risks clearly. Plan phased improvements. Write maintainable code quickly. Balance business and technical needs. For senior roles, they also want to see architecture judgment, decision-making maturity, stakeholder communication, risk management, delivery leadership, long-term ownership, ability to define MVP scope. Strong words to use in your answer. You can use words like check, balanced, prioritized, scoped, delivered, avoided over-engineering, reduced risk, documented, refactored, extended, validated, maintained flexibility, planned follow-up, protected maintainability. Example. I balanced delivery speed and long-term design by scoping the first release carefully, avoiding unnecessary complexity, keeping the code structure clean, adding tests, and documenting a follow-up refactor. Good speed versus long-term design topics you can use. Depending on your experience, you can talk about API delivered quickly, but designed with DTOs. Quick validation fix with later shared validator refactor. Search API with pagination from the beginning. MVP report feature with future automation path. Production quick fix followed by cleanup. Database audit table instead of temporary columns. Secure admin API. With limited first release, check. Dashboard MVP with reusable components. Temporary integration with future event-driven design. Simple caching strategy with future expansion. Monolith refactor before microservice extraction. Feature flag used for safe phased rollout. Final summary. Tell me about a time you had to balance speed and long-term design is an important interview question for software developers and senior engineers. The best answer should include: what deadline or delivery pressure existed? What long-term design concern existed? Your responsibility. How you evaluated trade-offs. What short-term decision you made. How you protected future maintainability. What tests or safeguards you added. What follow-up work you planned. What result you achieved. Good examples include focused API delivery, focused validation fix with future refactor, focused scalable search API, focused MVP report feature, focused production quick fix with long-term cleanup, focused database audit design, secure admin API, focused reusable dashboard design. The strongest answers show practical judgment, delivery ownership, technical maturity, and long-term thinking.